Network security for Azure ML is the last major topic in D1. 3, and it's increasingly tested as organizations push ML workloads into regulated environments. Let's cover the architecture. The core concept is the private endpoint. By default, an AML workspace is accessible over the public internet. You reach studio at ml.azure.com using a public IP. In a private workspace configuration, you create a private endpoint for the workspace inside your Azure virtual network. The workspace gets a private IP address in your VNet. And DNS is configured to resolve.api.azureml.ms to that private IP instead of a public one. Once this is done, you can only reach the workspace from within the VNet, directly via VPN or via ExpressRoute. No public internet access at all. Public network access disabled is the bicep property that enforces this. VNet integration for compute goes further. In a private workspace, your compute clusters and instances are also deployed inside the VNet. Their network interfaces are in a dedicated subnet that you specify at compute creation. Training data flows between the compute nodes and Azure Blob Storage over the VNet's private network, never over the public internet. This is the correct architecture when training on sensitive PII or regulated financial data. The supporting private endpoints. When you disable public access to the workspace, all the resources the workspace depends on also need private endpoints. The storage account, the key vault, and the container registry each need their own private endpoint in the VNet. This is why private workspace deployments require more upfront networking work, but the security model is much cleaner. No traffic ever traverses the public internet. Network security groups on the AML compute subnet control which traffic is allowed in and out of compute nodes. The required outbound rules for AML compute in a private VNet are documented by Microsoft. They include access to Azure Active Directory, Azure Container Registry, Azure Storage, and AML control plane endpoints. Failing to configure these outbound rules correctly causes training jobs to fail with network errors, which is a common real-world debugging scenario. The final security and governance topic for D1, 3 is source control integration. And it's broader than just check your code into Git. Azure ML has native Git integration that the exam tests in the context of experiment reproducibility and audit trails. Azure ML Studio notebooks can be connected directly to a GitHub or Azure DevOps repository. When a data scientist works in a connected notebook, saves are committed as Git commits to their current branch. This means every iteration of exploratory notebook code is tracked. You can see exactly what code produced what experiment results, and you can roll back to any previous state. This is the foundation of reproducible ML research. If a model performs unexpectedly well in production, you can trace back to the exact notebook state that produced the training run. The .aml ignore file works exactly like .gitignore. It excludes files from being tracked in the AML Git integration. Large data files, checkpoint files, output directories, these should all be in .aml ignore. You don't want training outputs committed to the Git repo. You want them stored in Azure Blob Storage as job artifacts. .aml ignore keeps the Git history clean and fast. Branch strategy for ML work maps well to standard software development branching. Data scientists work on feature branches, one branch per experiment or model iteration. When an experiment produces a promising model, the data scientist opens a PR. The PR review is where the team evaluates the code and the metrics before merging to main. Merging to main triggers the CI/CD pipeline that promotes the model to the registry. This workflow gives you both the exploratory freedom of branching and the governance of PR reviews before anything goes to production. Workspace level Git configuration links the workspace to a specific repository. Once configured, all notebooks in the workspace are automatically connected to that repo without individual setup per user. Configure it with AZML workspace update and the -git integration flag. For enterprise deployments with multiple workspaces, Set up Git integration as part of the Bicep provisioning template so it's configured consistently at creation time.